Today we are going to be taking a look at exponential functions and their graphs. So an exponential function is a function with a numerical base, and your variable is in the exponent, as opposed to the x being the base and a number being in the exponent. So that is an algebraic function. This is one of our transcendental functions. It's a number to a power that is a variable. So your variable is up in the power. When we graph these, I'm going to take a look at 4 to the x. That's going to be our base model. And I'm going to imagine putting in some numbers for x here. And I'm not going to write down a table for every one of these, but this is in my mind, this is kind of what I'm doing. What happens when x is 0? When x is 0, we have 4 to the 0, which is 1. So the point 0, 1 is on the graph. What happens when x is 2? When x is 2, we have 16. 4 squared is 16. So when x is 2, I don't know why I skipped 1. Should have gone to 1 next. Let me go to 1 next. When x is 1, 4 to the first power is 4. So 1 and then up 4 like that. When x is 2, we're up to 16. My graph only goes to 10, so it would be 6 higher than that, somewhere up there. What would happen if x was a half? What would happen if x was a half? If x is a half, we'd have 4 to the 1 half, which is the square root of 4, and that is 2. So when x is a half, we're up here at 2. What would x be if x was, or what would y be if x was negative 1? If x was negative 1, we'd have 1 over 4, so that would be way down here. Is there any value of x that we can put in, any negative value of x that would make this go below the x-axis? No. We'd have all these roots, and it would get smaller and smaller, smaller, way closer to 0. So we have this as our exponential graph of 4 to the x here. Something like that. It gets high very, very quickly. All right, on the same graph, we're going to do 2 to the x and compare those. So this time I'm not going to write the table. I'm just going to do this verbally here. So when x is 0, 2 to the 0 is 1. So we still have this 1. We're crossing right at where y is 1. When x is 1, we have 2 to the first, which is 2. So when x is 1, we're up here at 2. When x is 2, we're at 4. When x is 3, 2 cubed is 8. When x is 4, we would be up at 16. So this graph is going to look like, well, when x is negative 1, we'll be at 1 half. So this graph looks like this. Okay. What about if the base is 1/3? If the base is 1/3, if we put 0 in for x, 0 in for x, 1/3 to the 0 is still 1. We're still right there at that 1. What happens if we put a 1 in for x? If we put a 1 in for x, when x is 1, we'll have 1/3 to the 1, and that's just 1/3. So that's right here at 1/3. What happens if we put 2 in for x? 2 in for x would be 1/9. We're really close to the x-axis already. What happens when x is a negative 1? If I put a negative 1 in for x, I'll have 1/3 to the negative 1. It flips that and makes it 3. So when x is negative 1, we're up at 3. Negative 2, we would be up at 9. So this graph does that. So what did we learn here? If the base is bigger than 1, we have growth. It's growing. As time goes to infinity, our graph goes to infinity, our y's go to infinity. If the base is between 0 and 1, between 0 and 1, we have decay. That's exponential decay. It will never go below 0 unless we have a multiplier out front. Okay. 2 to the x minus 5, what is that going to do to our base graph? Well, that's going to shift our base graph to the right 5 units. It's not going to change the horizontal asymptote. We still have a horizontal asymptote right on the x-axis. Okay, let's put in some numbers. If we put 5 in for x, 5 in for x, 2 to the 0 is 1. What would happen if we put 6 in for x? 6 in for x will have 2 to the first, which is 2. 7 in for x would be 2 to the second, which is 4. 8 in for x, 2 cubed is 8. So this graph will go like something like that. Okay. What about number 3 here? We have 2 to the x plus 3. 2 to the x plus 3. Well, I can envision 2 to the x. 2 to the x would go in through this point, and it would go like that. Plus 3 is going to shift the whole thing down 3. So I take my base graph, and I shift it down 3 units. So I did have a horizontal asymptote of the x-axis. Now my horizontal asymptote will be down 3, up 3 units. Sorry about that. Up 3 units. Shift up 3 units. So I was going through this point, 0, 1. Now I'm going to be up 3 more units. So this, and then over 1 up 2, when x is 1, we'd have 2 plus 3 is 5, yeah. When x is 2, we'll have 4 plus 3, and that's 7. So this graph is going to look like this. Okay. What happens if we have a negative power? A negative power. Well, a couple different things I could think of this as. A couple different things I could do. I could just graph it as it is and say, okay, what happens when x is 0? When x is 0, I'm at 1. When x is 2, I'll have 2 to the negative 2. That is 1 over 2 squared. That's 1/4. So when x is 2, we're at a 4th. When x is negative 2, when x is negative 2, we have 2 to the negative 2. So that's 2 squared, and that is 4. So I know what my graph is going to look like. I'm going to go through 8 here and do that. Okay. The other way that we could have looked at this is, I have g of x is 2 to the negative x. That is 2 to the x, 2 to the negative 1 to the x, and that is 1/2 to the x power. And that's very similar. That is a decay. Remember, this is less than 1. We're looking at decay. Okay, good time to introduce e to the x. E is about 2.71828, and then it keeps on going. Okay, it's irrational. It's about 2.7-ish. All right. So for graphing purposes on these little bitty squares, I'm going to call it a little over 2.5. So e to the 0 is still 1. E to the 1 is a little over 2.5. Okay, e cubed. If you cube 2.5, what do you get? Okay, I think it's a little over 8. So maybe around there. Close enough. Very similar to, I'm losing my ink, my blue here. Very close to the 2 to the x or 3 to the x in between there. So e to the negative x. E to the negative x will be a reflection over the y-axis of this. So instead of going to the, instead of being a growth, it'll be a decay. So 2.5 here, 8.5 there. So we have this decay model. It does that. Okay, what about this one? This is our base e to the x. Right 3, up 5. So I'm going to take care of my horizontal asymptote, which is up 5. 1, 2, 3, 4, 5. There's my horizontal asymptote. And now I'm going to the right 3. Normally I go up 1 from your horizontal asymptote, but now I'm going to go to the right 3. Okay? And now it's an e to the x graph. So I go 2.5 up. It's going to look like that. Okay? What if we had negative e to the negative x? Negative e to the negative x. Well, let's plot a couple of points on this one. It never hurts to plot a couple of points. What happens when x is 0? When x is 0, e to the 0 is 1, but this negative is going to rule, and it's going to be a negative 1. Negative 1. What if we put a 1 in for x? If we put a 1 in for x, e to the negative 1 is like 1 over e. So 1 over 2 point something, but it's negative. So when x is 1, negative e. So from those two, I know what's going to be happening here. When x is 2, I'll be down at e squared, going negative, negative e squared. This graph is going to do this. The negative flips it over the x-axis. Okay. Never hurts to plot a few points, as long as you can do it fairly quickly. So, just a recap for what we found when we were experimenting with these graphs. If you have a times b to the kx, where b and k and a are constants, okay, a is called the initial value. That is the value when x is 0. So if x is 0, b to the 0 is 1, and you'll be left with a. That's your initial value. If b is greater than 1 and k is positive, you have growth. As x goes to infinity, the function goes to infinity. This is the graph of 2 to the x. If b, your base, if your base is between 0 and 1, you have decay, as long as your k value up there is positive. So decay, this is the graph of 1/2 to the x. As x goes to infinity, what does your function value approach? It approaches 0. Okay, how might you be given some questions? Here are some random questions. Okay. I give you f, g, and h. Which of the following is true? Is g of 3 greater than f of 3? Well, here's g. Let's go ahead and find out. 3 over 5 cubed, is that greater than 2 over 5 cubed? Well, this is 27 over 125, and this is 8 over 125. Is that bigger? It sure is. So that is true. Is the limit as x approaches infinity of h 0? Well, the base is between 0 and 1. And as x goes to infinity, this is going to go to 0. Yes. If the base is between 0 and 1. Okay, what about this one? The limit as x goes to infinity of f all to the negative 1 power. That is 1 over f. So this is the limit as x approaches infinity of 1 over f of x. All to the negative 1. If the negative 1 was in here, that would be a function inverse. We're going to do that tomorrow, but we're not doing that today. This is just the entire function to the negative 1, that is 1 over that function. Okay? So this is f of x is 2 over 5 to the x. 1 over that, 1 over f of x. Another way to think of this is f of x to the negative 1 is 2 over 5 to the x to the negative 1, and that is 2 over 5 to the negative x, which is 2/5 to the negative 1 all to the x power. That is 5/2 to the x. This is 5/2 to the x. As x goes to infinity now, the base now is bigger than 1. And as x goes to infinity, this is growth. And so this will be infinity, not 0. So 1 and 2 only are true. Number 2. G is given by 81 to the x over 2. Which of the following expressions also defines G? I take a look at the expressions, and some of them have a 9, some have a 27. Let's take a look at this. I have 81 to the x over 2. That means the square root of 81 all to the x power. The square root of 81 is 9 to the x power. That's choice A. That was an easy one. Okay. 25 to the x. Which of the following is also the same expression, or represents the same expression? Well, 25 to the x. 25 is 5 squared. True? That is 5 squared all to the x power, which is 5 to the 2x. B. Number 4. They're changing this to something else, and I see that we're dealing with 2 times 16 to the 3x. That is 2 times 2 to the 4th all to the 3x. And that is 2 times 2 to the 12x. And now we have same bases being multiplied, so it's 2 to the 1 plus 12x. We add those powers. C. Do a couple more. Number 5. This table gives values of the function f for selected values of x. Which of the following could be the function for f? Okay, let's think about this. Okay, when x is 0. When x is 0, hang on. I'm going to shut that door. Alrighty, I was about to get a little bit noisy downstairs. Alrighty. When x is 0. When x is 0, we need to get 4 for our function value. When x is 0, here, when x is 0, 9 to the 0 is 1, 3 plus 1 is 4. That checks out. So this is still in the running. When x is 0, 3 to the 0 is 1, 4 times 1 is 4. That one checks out. When x is 0, 9 to the 0 is 1, 4 times 1 is 1, that one checks out. 3 to the 0 is 1. 3 plus 1 is 4. That one checks out. So they all check out for this one. Let's go to the next one. When x is 2. When x is 2, 9 squared is 81 plus 3 would be 84. We do not have 84, so not that one. Okay, when x is 2. When x is 2, 3 squared is 9. 9 times 4 is 36. That's exactly what we have here, so he's still in the running. Okay, when x is 2, 9 squared is 81 times 4 is not 36. 3 squared is 9 plus 3 is 12, not 36. That one took care of it. This must be B. So lots of times you go through and you see which one will work. Let's do another one. The function f is given by 3 to the x. The function g is given by f of x divided by 27. Which of the following transformations of the graph of f describes the image of the graph of g? G is f divided by 27. Well, f is 3 to the x, so g is 3 to the x divided by 27. I see same powers. Same bases. I see same base of 3. So this is 3 to the x divided by 3 cubed. Same bases, so this is 3 to the x minus 3. That's g. That's f. What's the translation? Write 3 units. B. Write 3 units. Number 7. F and g are given by f is this function, 5 to the x. G is this function, 5 to the x times 25 to the a. Which of the following describes the relationship between f and g? Well, I'm going to deal with g. F I can't do a whole lot with, but g I can do something with. So I'm going to mess with g over here. G is 5 to the x times 25 to the a, which is 5 to the x times 5 squared to the a, which is 5 to the x times 5 to the 2a, which is 5 to the x plus 2a. So how do f and g relate? Well, g is a shift to the left 2a units. Left 2a units, so horizontal by negative 2a units. D. Number 8, last one. All right, again we have f is 3 to the x, g is f all to the negative 1 power. That means 3 to the x all to the negative 1 power. That means 3 to the negative x. So g is 3 to the negative x. Okay. Oh, this is a copy. Never mind about that. I'm going to get rid of that for your paper. Okay. So, which of the following is true? G is a reflection over the x-axis of a reflection of f over the x-axis and is growth. I know it's not growth. Okay, I know it's not growth because this is 1/3 to the x. Yeah. So I know it's not growth. I know it's decay. And is it a reflection over the x-axis or the y-axis? It is a reflection over the y-axis. An x-axis would have a negative out in front of the whole thing. So this is, oops, I'm going to fix that for your paper again. That says D. I can always tell when I copy and paste and don't fix. Okay, so those are some random AP style questions for exponentials.